Hello and a really big warm welcome to this presentation from the Urban Penguin. My name is Andrew Mallett, and in today's video we're going to look at how we can build a shell script to show the manufacturer or the OUI of the network cards that we are using. It's going to be a relatively simple matter of extracting the MAC address from our network cards and then going through and comparing them to a text file that has all of the manufacturers. But we'll be using a combination of tools within our script. So we'll be looking at GREP, we'll be looking at awk, we'll be looking at cut, as well as the translate command. Putting these tools together, we're going to give you something really useful from the command line. So come on, let's see if we can find that command line. And wouldn't you know, here we are at our Pixel Playground. And I don't think you could find a better Pixel Playground than a Raspberry Pi. Although it doesn't really matter what system that we will be working on, we're going to develop this on a Raspberry Pi, but we'll also see it running on an Ubuntu system and on a Rocky system. But it really shouldn't matter, just the files are going to be located in slightly different locations. Now, as I say, what we want to be able to do is when we look at our network interface cards, so if I go through and have a look at IP, link and show, we're going to be able to see, well, wouldn't you guess, we're able to see our network cards. Now, included in our network cards, we have the ether, and the ether then is pointing to the MAC address, the media access control address of our network cards. Now, that's made up of 6 hexadecimal numbers, and we can see they're separated by colons. The first 3 numbers represent the manufacturer of the card. The last 3 numbers, really the serial number, identifying that card in that manufacturer. Now, our manufacturers should be listed in our hardware file. We might have to install a package to be able to get that, but we can then go through and query the manufacturer. So rather than just looking at our output like this, we could see the manufacturers of the cards. So to be able to do that, the first thing that we have to do, I suppose, is isolate the MAC address. Now, one easy way that we could do this, let's go through and clear the screen. I can use my IP link command again, but we can abbreviate it to IPL for IP link, and the default action is show. Now, of course, though, if we are using a script, putting it in longhand is going to be more readable, and that's what we want in the long term. But it's fine at the command line. So let's do our IP link, and we can go through then and pipe to grep and search for ether. When we look at the output then, we're only seeing the MAC address that relate to Ethernet cards, so we've been able to isolate it. However, when we look at this, we have to be able to decide how we can get to that. So I would need to perhaps squeeze some of the leading spaces. I'd need to look then for the second field. So I'd need to use probably TR for translate and cut to make sure we've got the correct fields. Also, when we go through and take a look at the underlying files, and on an Ubuntu-based system or a Debian-based system such as Raspberry Pi or Ubuntu, we can go through, and I'm just going to look at the head of /usr/share and ieee-data. This is from the ieee-data package, and we can look at our OUI.txt. And if we look at this, the way the address is written, it's not using the colons that we use within the IP command, it's using dashes. So we need to make sure that we're looking at the correct format of our information. So if I clear this screen, let's go through and just do a Control and L, and we can then go back up. But instead of using grep, we're going to use its big brother, which is awk. With awk, we can go through and specify what we want to do inside of single quotes. And we can go through and still search for ether, so delimited with forward slashes to say it's a regular expression we're looking for. And then our main command is inside of the brace brackets. And we can actually run several commands. The first thing I'm going to do is actually do a global substitution. So this is a function. We want to then go through and substitute the colons, comma, for dashes or hyphens, however you like to call them. We can then close off our function. Now, when we're looking at separating arguments within a function, we use a comma. But when we're separating our commands, be it at the bash shell or be it in awk, we use a semicolon. So that's done our translation for us. We then need to make sure that we're grabbing the right information. So we can then go through and specify that we want to print the second field. We can close off our brace brackets. We can then go through and close off our quotes. Now, when we look at it, we've easily been able to extract the information that we need. If we want to take this one step further, we can go through and pipe our output, so using the vertical bar, and pipe it to translate. And we can specify then two strings. The first string is going to be what we want to translate. The second string is what we want to translate it to. It's a little bit long-winded, but we can go through and put our square brackets and colon and translate our lowercase characters, close it off in a similar way. So we can close that off, close off our string, put a space then for our second argument, open up our second string, and then this is going to be very similar. We can probably guess we want to uppercase it now, so we can go through and put these in. And these are really powerful tools that are part of your armory, and we can see now that we've easily been able to translate through to uppercase and making sure that we've got the correct format for our MAC address. The next thing to do is actually go through and search for one of these MAC addresses. We could go through then and perhaps if we wanted to, just maybe send this to a temporary file. So let's go through and send our output to mac.txt. Now that we've got that, we can go through and take a look at our max.txt, and we can see then that we've got those entries. So we can take this then into a looping structure where we can go through and say while read. Necessarily, we can say just read raw data, so everything is read as a literal, into a variable, let's say, called Mac. And we can then go through and start our looping structure. So this looping structure that can do a lot of our work. And say we want to then pull out the first three fields where we've delimited with a dash. And we can do that using the cut command. So -d, where our delimiter is the dash or hyphen. And the fields that we want are fields 1 through to 3. So this is going to give us our OUI, or our organisationally unique ID. We can go through and specify done, but don't hit enter yet because we've got to read in from our max.txt file. So you can see now that we've got the UIDs coming out, and then we can go through and maybe search for one of those. So if I go through now and use a GREP, where we can search for E4-5F-01 from our /usr/share/IEEE-data and then our OUI.text. Now you can see we get our information coming back, but the problem is, even though we could probably relatively easily get to the third field, we need all of the fields after the third field. Here we've got 4 space-separated elements of a name, Raspberry Pi Trading Limited. And of course, this won't be just the Raspberry Pi. There will be many manufacturers that perhaps then make up more than one word. So we have to play around a little bit to be able to extract that data. Now, of course, we're not going to do it from the command line. We want it to be done from the script, and we want it done reliably each time. So this is where your shell scripting skills come in. If we go through and open up a new file, so if I go through and Vim, obviously you can use any editor that you want, and we can call it, let's say then, our mac.sh. We've got our shebang. Then we need to go through and work out what operating system we are working on. So we could do this by reading from the OS release file. On a Debian-based system such as Raspbian or Ubuntu, our ID-like field is going to be set to a lowercase Debian. If we're running on something like a Rocky Linux system, then it's going to be set to RHEL, CentOS, Fedora. So an easy way to test this is to then go through into our if statement, and we can go through and specify if we're a Debian-based system, then our file is going to be USR share ieee-data OUI.txt. Else, so this is going to be for our Red Hat systems, we can go through and pick it up from USR share hw-data OUI.txt. Now, of course, the locations may differ on many other distributions, and you can also then find out where that file is going to be on your system. But this is going to be good for our Debian-based systems, so Ubuntu, Raspbian, Debian itself, and for a lot of Red Hat-based systems, such as Red Hat themselves, CentOS, Fedora, Alma Linux, Rocky Linux. We need to set then our file variable to be the lookup database that we want. Now, we were working on the command line on our Raspberry Pi, so of course we were looking in the USR share ieee-data OUI.txt. But as we see when we look on our Rocky system later, it's going to be located elsewhere. We can check to see if the file exists. So again, we've got another if statement going on here. Let's just move some of this out of the way. And we're actually looking for a negative check here. So if not a regular file, $4 file, then we can specify that a file's not found. So that's going to be a matter then of installing the ieee-data package for Debian or the hw-data package on RHEL-based systems. And we can then exit the script. There's no need to process anything else. As we start then moving down our file, this is where our main work is taking place, and we can go through, and as we saw from the command line, we can go through and display our network cards. So the IP link show command. And then from here, you can see then that we are running through to awk, where we're searching for ether and replacing our colons with a dash and returning just the second field. We go directly into our while loop. Inside of the do loop, the first thing that we're doing here is setting the OUI ADDR variable. You could call it anything, but this is the OUI, our organizationally unique identifier. So we go through, as we saw within our looping structure before, and then cutting each of our MAC addresses that we pass through, cutting them on the delimiter dash, and displaying them fields 1 through to 3. We're making sure then that we translate that from lowercase to uppercase. And then we go through and create another variable. And this time we're just calling it entry. Remember, these variable names, you can call anything that makes sense to you. For our entry variable, we're going through and ensuring Again, we can make this a little bit more readable. Let's move this down a little bit, move the if statement down a little bit. But for our entry variable, we're running then our grep search. We only need to match on the first occurrence. Normally, grep is searching globally. I've included the -i just in case translation didn't happen, but we know it's there, so technically we could drop that. And we can then go through and search for our variable OUI address inside of our file. You can see the importance of using variables. So even though we're searching now different files, whether we're on a RHEL system or whether we're on a Debian-based system, the variables then make things work for me. If we have got a correct entry for our entry variable, then we can process it. As we go through then processing it, this is perhaps in some ways the awkward element that we were looking at before. Let's just move some of this down. This is where we then search our file and get our result coming back. But our result coming back is going to include both the OUID, the fact that it's in hex, and then it's going to include the manufacturer. So one of the easy ways to deal with this is make sure that our first field, which is the OUI, we can make sure that that's empty. The second field, which then just says whether it's hex or whatever format, we can make sure that they're both set to empty strings. That's going to leave us a couple of empty spaces at the beginning of the line. So we can remove those empty spaces by doing our global substitution in awk, looking for lines that begin with 2 empty spaces and then replacing it with an empty string. We can then print out the complete line. The complete line, or what's going to be left, is the complete manufacturer name. Now, that might be a single word, or it might be multiple words, as we were looking at with the Raspberry Pi. Else, then we can say, well, look, we did the lookup, but we didn't get anything back in our entry variable, so the MAC address was not found in that file. We can close our if statement, and then we are done. But this then is our script. The script is also going to appear in the description of the video so that you're able then to try it out on your own systems. And remember, if you do like this and find it useful, then do hit the like button. Hitting the like button or the subscribe button is going to help promote this video so other people can find it too. But let's go through and then save our changes. Now remember, I had changed it, but only added in extra white space. So technically I could have dumped those changes. But let's go through and just run it with bash. I haven't made the script executable at the moment. But if we go through and run bash against our last argument, you can see then that I've got 2 network cards that are identified as being part of Raspberry Pi. The third network card is actually coming from my Docker network, so that then is not included in the ieee-data file. So this is good. It's worked then on my Raspberry Pi system. And if I go through and take a look at cat/etc/os-release, that we're going to be able to see the id_like variable is set to Debian. So this is how we can start determining which operating system we're working with. If I go through and take a look at the Ubuntu system, and if we go through and run our mac.sh here, well, we've got 1 network card. It's a virtual network card. This is a VMware-based system, and it's coming back then as being owned by VMware.inc. I have another system, a Rocky system here. And if I go through then on this one and run the same thing, we've got the correctly formatted MAC address, but it's not found in our hardware data OUI.txt. So it's a different location we are searching. So that has worked for us. This is a VirtualBox machine, and VirtualBox didn't seem to have then its network cards added to the hardware text file. But again, I can go through and cat out our /etc/os-release file here. And if I can get that right, I hit the wrong key. We can see then the id_like includes RHEL, CentOS, and Fedora. So that we're able then to run the script slightly differently, depending on which system that we're working with. And the file that we're reading from on this system is going to be then our USR share. It's the ieee-data package instead of the ieee-data package, and then our OUI.text, if I can spell that correctly, OUI.text. And we can then go through and see all of the manufacturers that we have in this file. So hopefully this has been useful to you. Let me clear the screen. As I go through then and cat out the mac.sh, you can see this is the script that does the work, and it's going to do the work for you no matter which system you're looking at, being a Debian-based system or a Red Hat-based system.
All that is left to say is thank you for watching. If you've enjoyed this, then you are probably sadder than I first thought. For more of this drivel, please subscribe, like and comment to @TheUrbanPenguin.